Okay, so in this section, we're going to talk about what happens if we change dimensions of a shape. So how does that affect area, perimeter, circumference, based on how many dimensions we change and how many dimensions are in our shape. So first, if we look at this triangle with a base of 12 and a height of 5, we want to ask ourselves, well, how many dimensions does it have? So dimensions are basically like unique measurements that we use to calculate, right, area of your shape. So what I always like to look at, if I'm not sure how many dimensions a shape has, because we're not talking about like 2-dimensional or 3-dimensional here, we're talking about like length and width, right? How many different dimensions are there? So I like to take a look at the area formula to help me out. So if you imagine an area for a triangle is 1/2 times base times height, there's 2 unique measurements we need base and height to calculate the area. So in this case, this shape has 2 different dimensions. Okay, so what we're going to do right now is we're going to be looking at the effect of changing just one of those dimensions. So just as a quick exercise, let's take a look and find the area of this existing triangle, which we know is 1/2 base times height, so half of 60 is 30. Now, what happens if we just double the base? So that means we're doubling the base and keeping the height the same. So now my base instead of 12 is 24. What happens to my area now? So go ahead and calculate that. Right, so if we doubled the base, kept the height as 5, we'll get 60 square inches as our new area. Now what happens if we have the length of the base? So instead of being 12, our new base is just 6. So go ahead and calculate that. So then we get our new area as 15 square inches. So if we kept one dimension the same but changed the other, what do we notice about the change in area? Well, if my original area was 30, 30 times what is 60? Times 2, right? 30 times what is 15? Times 1/2. And those are the same factors that we use to change the dimension. So what's cool about this is if we have more than one dimension to our shape and we change one of those 2 dimensions, or yes, one of those 2 dimensions, the area is going to change by the same factor as that one single dimension. The area is multiplied by the same factor as that same one dimension. So with our triangle situation, doubled the base, which is times 2, so I doubled the area, 30 times 2. Then I have the base, so I did times 1/2. Then I did area times 1/2 to get that 15. So this is a shortcut that works if we are just looking for the change in area. So that's a relationship that we want to be aware of. Now, of course, we don't have to be limited just changing one dimension. We can now change all dimensions. So first we have to think about, wait, what do you mean by all dimensions? Don't you mean 2? Well, it depends on the shape. What is considered all dimensions? So remember, we're not thinking about the idea of 2D or 3D in terms of our shape, but we're thinking about the measurements, those unique measurements. So again, think about your area formulas. So for example, going back to that triangle, right? Area is 1/2 base times height. Here, all dimensions mean both base and your height, right? Now, if you're thinking about the area of the circle, which is pi times radius squared, there's only one variable here. So all dimensions is just the radius. So there is only one dimension there. So if you change r, you change it all. So that's not changing one, it's changing all. So I would just say, look at the area formula or the variables. And that'll help you out, because remember, pi is a number, pi is not a variable, right? So in terms of the circle situation, r is the only dimension. So if you change one, by default, you change everything. Versus if you look at the triangle or a rectangle, right? Base times height, you have 2 different ones. If you change b, h doesn't have to change. So what you're basically thinking about here is when we change all dimensions, we're creating proportional shapes, we're creating similar shapes. Versus if we change one dimension, it's not going to stay the same type of shape. Okay, so that's something else to think about too. If you visually imagine, if I change the radius or if I change the height, does that give me a similar shape? If yes, then I've changed all dimensions. If no, then I've probably only changed one. Okay, what's interesting, I should mention, is the trapezoid. If you want to write this down, the trapezoid has 2 different bases, B1 and B2. They're the same variable, so together the 2 bases are 1 dimension and the height is a 2nd dimension. So if you want to change just one dimension of the trapezoid, you either change the height or you change both bases by the same factor. So that's an interesting side note. Okay, so let's actually run through the same kind of activity here. I want you guys to look for a pattern. So let's find the perimeter and area of each, and perimeter is also, remember, circumference. Oops. For the circle. So go ahead and find the perimeter or circumference and the area of each, leaving your answer in terms of pi, and then same activity as before. What happens if we double all dimensions for both? What happens if we have all dimensions for both and come up with those numbers? So let's go ahead and check all your calculations. So remember, area of the circle is pi r squared, circumference is 2 times pi times radius, leaving pi in our answer. We'll get 144 pi square inches as the original area, 24 pi as the circumference. Rectangle, pretty straightforward, base times height for the area, so we get 30.6 square meters, that's the original area. And then perimeter, add up all 4 sides, opposite sides are the same, so 6 plus 5.1 plus 6 plus 5.1 gives us 22.2. Now if we doubled all dimensions, in the case of the circle, there's only one dimension, so we're doubling 12, so the radius now becomes 24, and then we can see how that changes area and circumference. And then with the rectangle, doubled both the base and the height, so height becomes 12, base becomes 10.2, and then we do our new calculations. So just looking at the right here on the left, when we've doubled the measurements, the dimensions, what happened to area, what happened to circumference? So do you guys see a pattern? And as a hint, if you're not sure, try dividing and see if you come up with something. All right, now let's try the same thing with the halving. So if you look at the 36 pi square inches, the 7.65 meters, when we halved the radius to make it 6, when we halved the length and the width of the rectangle, we have these two new areas. How does that compare to the original? How does the circumference and the perimeter compare to the original? Well, hopefully you realize perimeter got multiplied by the same factor the dimensions did. So if I doubled the radius, circumference doubled. If I doubled the base and the height, perimeter doubled. But with area, it was different. Because if you did that division, you'll realize, wait, I doubled the dimensions, but area multiplied by 4. I have the dimensions and area ended up being multiplied by 1/4. So what's cool about this is if we have these similar shapes, if we're multiplying our dimensions proportionally, then perimeter gets multiplied by the same value as the dimensions, and area gets multiplied by that factor squared. So that is the pattern here when we're changing all dimensions proportionally when we're making similar shapes. Right? So all the dimensions, that remember all, if you're looking for, wait, am I multiplying one or is it considered all? Look at the area formula and look at how many unique dimensions there are. If there's only one dimension, by default, you're multiplying all, right? So anyway, we're going to multiply dimensions by some value x, like 2, 1/3, 15.5, right? Whatever that is. Then instead of having to actually work with the dimensions of the shape to calculate perimeter or circumference, we can just take the existing perimeter or circumference, multiply it by x as well. To find the new area, rather than having to dig out the formula or worrying about how to find missing measurements, we just take the original area and multiply it by x squared. All right? And you can also work backwards. You can say, oh, the new area is this. What was the factor? And we can work backwards. So these are relationships that we want to work with. So we have a few examples to help us with that. And that'll wrap up this section. So example 1, the height of a triangle is multiplied by 6. What is the effect on the area? So the first thing I do is I determine how many dimensions were changed. So I like to look at my area formula. So I'll star that just to remind you. Area is 1/2 base times height. If I'm looking at, okay, the height is multiplied by 6, so only height got changed. So there are 2 dimensions, but there's only a change in 1 dimension. So then I can think, okay, well, what's that effect on area? If I scroll all the way back up on my notes, 1 dimension was changed, area is multiplied by the same factor as that dimension. So area is multiplied by 6. And there you go. If you want to do a calculation, you totally can. It's just a little bit more work, so that's why I encourage you guys to know your shortcuts. If you want to do the calculation, I'll just show you really fast. Right? We don't actually need to know the dimensions. We know that area starts off, I'll put A1 as the initial area, right? Or A0, I'll do that. A0 is what we start with. So that's 1/2 base times height. And then our new height for our new area, so I'll call this A1, is 1/2 base times 6h. If Can't tell that's a 6. So then I can see, okay, let's simplify this. This becomes 1/2 of 6 times base times height. So that's 3BH. So how do I tell what happened to it? I look at the division. So A1 over A0 will tell me what that relationship is. So 3BH over 1/2 BH. The B and the H cancels out. 3 divided by 1/2 equals 6. So we can still see areas multiplied by 6. So you can always do that if you'd like, but I think it's a lot faster if you kind of know the relationships. So that's what I'm going to be showing you right today. So example 2, the radius of a circle J is multiplied by 1/5. What is the effect on circumference and area? So again, I start off with the area formula. Area of a circle is pi times radius squared. In this case, there is only a single dimension. So if you change one, you change it all. So we've changed all dimensions. So then if I just refer back to my notes, right, scrolling back up just a little bit, circumference is multiplied by the same factor, 1/5. Area is multiplied by 1/5 squared. So circumference is multiplied by 1/5, and area is multiplied by, and let's go ahead and multiply that out, 1/5 times 1/5 is 1 over 25. Right, again, why don't I have to give you the actual area or the actual circumference? It's because the directions say we're looking for the effect. We're not actually looking for the actual value. So make sure you read through the directions carefully. All right, one last one here. We're dealing with a square. Square has an area of 36 square meters. The area is doubled. What is the effect on the side length? So this is a little different. We're saying, hey, I'm telling you the old area is 36. The new area is 2 times that, so we can figure out that's 72. What was the change in the side length? So once again, we want to think about, okay, what's true about my area formula? What's true about my square? So if you think a square, right, all 4 sides are the same. So I know a lot of us want to say, okay, A is base times height. Remember, all these are the same. So I can call that S, 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 and S. So this is really S squared. So there is really only one dimension to a square. So that means all are changed if we change just one of these. So I'm looking at the situation of all dimensions are changed for this square. So if we go back and look, we want to think about, okay, what's the effect of area, right, if we've changed all the dimensions? So we said, okay, area is multiplied by some factor, I'll call that x squared. So basically what we're doing is we have your original area, right, which is 36, our new area, which is 36 times 2, which is 72, and we're saying, hey, if I took this 36, multiply it by some x squared, I would get 72. So then I can just solve this. So dividing both sides by 36, x squared equals 2, square root both sides, x equals the square root of 2. All right, we don't want to put a plus or minus here because we're not going to multiply a side length by a negative radical. So here we can say the side length is multiplied by the square root of 2. And that's it. So we want to make sure we practice this because I know it sounds a lot easier than it probably is. So you want to make sure you look through your directions, read everything carefully, know how many dimensions consists as all, right? And then what we mean by just one dimension if we have more than one dimension in our shape. All right, thanks for listening.